हॅलो फ्रेंड्स, हाऊ आर यू? मजेत ना? असायलाच पाहिजे. माय सेल्फ मिस्टर नरेंद्र जंगले फ्रॉम गोखले एज्युकेशन सोसायटीज RM Bhatt High School, Parel. Welcome students. Today we are going to study 9th standard Algebra, 3rd chapter Polynomials. Now, before studying this polynomials, we must know about this algebraic expressions. So what is meant by algebraic expressions and what are the types of that algebraic expressions? So let us see that algebraic expressions first. So algebraic expression means generally we say the mathematical terms that contains variables and numbers. जिसमें वेरिएबल है और कुछ नंबर्स है, कुछ प्लस माइनस ऐसा साइन है, दैट इज कॉल्ड अल्जेब्रिक एक्सप्रेशन. फॉर एग्जांपल, दिस 2x square plus 3x plus 5. This is an algebraic expression that contains some variables, that contains some numbers, constant terms, coefficient like this. Here, this 3x square plus 5x, this is also one of the algebraic expression, and this one means only 5. This is also the algebraic expression. Now you say, sir, here variable is not there, but every constant, with every constant variable is there. So let us revise that indices. So here x raised to 2. So what is the power of that x? The power is, here it is the power. Power means index, जो ऊपर नंबर है वो. Here power is 2. If we write root x, the power becomes x raised to half. Cube root of x means x raised to 1 upon 3. And when we write 1 upon y, then the power is minus. So here, and when we write only 2, then you know every variable raised to 0, x raised to 0 is always 1. So this 2 is nothing but 2x raised to 0 is equal to 2 into 1 is equal to 2. Means every constant, with every constant x raised to 0 is there. Means that variable is there. Therefore, only number is also called a algebraic expression. So I remember this one, because we have to concentrate on the power only, power index of that variable. So here I am writing some algebraic expressions. Here these are the 3 examples. First, second, third. Now fourth one is root 3 by 2 y plus root 5. This is fourth example. This is fifth example. Root x plus root 3. And sixth example, this 2 into 1 upon y plus 3y plus 5. So these are some algebraic expressions. Now let us see how to define that polynomial. So which one is the polynomial that we have to decide. So that is our first point. Identify the polynomial or define the polynomial. So polynomial is an algebraic expression. That is the first thing. So these are some algebraic expressions. But all algebraic expressions are not polynomials. सभी जो कुछ algebraic expressions हैं वो सभी polynomial नहीं है. So we have to identify which one is the which algebraic expression is a polynomial and which is not a polynomial. So we have to concentrate only the power of variable. We have to observe the power of variable. So what we have to see, either it is positive, either it is negative, either it is zero, or it is fraction. So that we have to observe. That means जो पावर है ये x रेस टू 2, यहाँ पे x रेस टू 1, यहाँ पे x रेस टू 0, यानी कांस्टेंट टर्म मींस 0. तो we have to see whether the power of that variable is positive. पॉजिटिव यानी अगर 2 है तो पॉजिटिव आ गया, नेगेटिव 0 या फ्रैक्शन. So if we observe first polynomial, in first polynomial the powers of x, here this is the first one, power of x2, it is the positive. Here x raised to 1, if no power is there, that means 1 is there, so it is also the positive number, means whole number, it is 0 here, x raised to 0. So here in this first example, all this variable means powers of the variables are whole numbers. Whole numbers, you know, whole numbers means this w is equal to 0, 1, 2, 3, 4, 5 and infinite. These are known as whole numbers. So here the power is whole number. Whole number, or we can say either 0 or positive. The power is either 0 or positive, or it is whole number. In second example, here it is the plus 2, here it is 1, means here again the whole number, here x raised to 0, whole number. Here root 3 by 2 y. Think whether the power is negative or positive. Here the power of y is 1, it is the coefficient, no need to say this one. This is a constant term, root 5, this is the coefficient, here x raised to 0, the power. So here again the whole numbers, but here this can be written as x raised to half, root x means x raised to half plus root 3. So here the power of that variable is not a whole number, here it is 0, but everywhere it is whole number. So here the power of variable is fraction. Here this can be written as 2 y raised to minus 1, because 1 upon y means minus 1, plus 3y plus 5. So here the power is negative, here it is 1, here it is 0, but here in first term it is negative. So how to define that polynomial? If the power of variable in the given algebraic expression, if the power of variable is a whole number, then the algebraic expression is called polynomial. And whenever it is fraction or it is negative, then it is not a polynomial. So in the sixth example, first one is a polynomial, second one is a polynomial, fourth one is a polynomial, fifth is not a polynomial, and we have to write the reason. Because the power of variable is a fraction. And here, what is the reason? The power of variable is negative. So we can write the definition of polynomial. So polynomial, an algebraic expression in which all the powers in bracket index of variables are whole numbers. Whole numbers means either positive or 0. The number is either positive or 0. Then the algebraic expression is called polynomial. This is called polynomial. So here remember two things. The first one, the power of the variable, and it is always a whole number, means positive or the zero, then it is called polynomial. So in this way, in above examples, the first one, second one, third one, fourth one are polynomials and the remaining are not polynomials. So this is our first part in this chapter, to identify whether the given expression is polynomial or not a polynomial. Means we have to check. ये हम लोग को decide करना है, check करना है. Our next point is constant polynomial. So what is meant by constant polynomial? If only one constant term, means only number is there, then it is called a constant polynomial. So here this only number means 6 minus 7 root 3 by 2, all are constants. Constants means number only, no variable. But you know variable is there. The index of variable is 0. 6x raised to 0. X raised to 0 is 1. That's why it is 6. All are constants, are called constant polynomial. Means if only number is there, means only 6, then these types of polynomials are known as constant polynomials. Next one is zero polynomial. What is meant by zero polynomial? Zero polynomial, this is the next term, zero polynomial. If there is no term, means nothing is there, then that is called zero polynomial. Only 0 is there, then it is also a constant polynomial. Here 0 is there, then that is constant polynomial. Now let us see the types of polynomial. So types of polynomial means these are based on the types we see: constant polynomial, zero polynomial, and these are again types of polynomials which are based on number of terms, which are based on number of terms. Means how many terms are there? You know, the terms are separated by plus and minus only. So first type is monomial. The polynomial which contains, or directly we can write polynomial containing or having only one term. The polynomial having only one term is called monomial. So here some examples are there. Examples: this 3x square, 5x, this 8. These are the examples of the polynomials. Single polynomial means only one term is there. This 3y cube, all are the single term, means these are called monomials. Now second point is binomial. Means two terms are there. Bi means two. The polynomial having two terms is called binomial. Bi means two. So here remember, this contains monomial means only one term. This contains two terms. Binomial means two terms. That is important. So remember, examples are, so 3x square plus 5x, two terms are there. Because of the plus and minus, the terms get separated. Second example, this 5y square plus 3. This is also the example of binomials. Root 3 by 2 x cube plus root 3. This is also example of binomial. So third one is called trinomial. So trinomial means contains 3 terms. Trinomial. Tri means 3. This tri. Mono means 1. Bi means 2 and tri means 3. So the polynomial having 3 terms. Polynomials having 3 terms is called trinomial. So 3 terms means examples are, first example 5z cube plus 5z square plus 5. So this is 1, 2, 3 terms, trinomial. Then root 5y square plus 3y plus 2. This is also a trinomial. So these are the examples of monomial, binomial and trinomial. So here, how to write that polynomial? We can write the polynomial. We indicate the polynomial by p means this polynomial. Suppose this one, second example. This is written as px, means polynomial in x. 3x square plus 5x. Here it is the polynomial in z. So we can write pz is equal to 5z cube plus 5z square plus 5, means polynomial in z. Here it is the polynomial in y. So py is equal to root 5y square plus 3y plus 2. So in this way we can write the polynomials using this letter px, py, pz like this. The pz, py, that x, y, z indicates the variable. X variable, y variable, pm variable is there, pm. X variable is there, px. Then n variable is there, pn, like this. So p means polynomial and in bracket there is a variable. Let us see degree of polynomial. This is also very important point from this chapter. How to find the degree of polynomial. Now degree of polynomial. Degree of the polynomial. You know the highest power of variable in 8th standard we studied this definition. The highest power of the variable is called degree of that polynomial. But this is when if only one variable is there. Some polynomials contains one variable, some polynomials contains two variables. So whenever one variable is there, then we can use this method. So if single variable means, for example, this first example, this 5x square plus 3x plus 2, this is an example. So what is the degree? The highest power of the variable, here power is 0, here power is 1, here power is 2. So degree is 2. Then second, this 7y raised to 8 plus 6y plus 3. Here highest power is 7, therefore degree is 7. So in this way, if single variable is there, means only y is there, x is there, then we can write using this method Now, if two variables are there, means more than one variables are there. Degree of a polynomial. Second point, how to write the degree of a polynomial. This may be asked for question number 1. In question number 1 for was 1 mark. Having or with more than one variable. So some examples are there here. If we consider the examples, 3m cube n raised to 6 plus 7m square n cube and minus mn. Then how to write? Because here m and n, two variables are there. So n, the highest power of n is 6. Here 3, 0, 3 and 6. Highest power of m is 1, 2, 3. Then how to decide? So first find the sum of powers. So here what we have to find? Sum of powers in each term. So first we have to find sum of terms in each term. Then highest sum. The next point is highest sum of powers is degree. Second point, highest sum is degree. So let us see, find the sums of the powers. So here, if we see the powers 6 plus 3, here sum is 9. Here 6 plus 3 is equal to 9. In second term, it is 2 plus 3. It is 5, and here 1 plus 1, it is 2. So what is the degree? The highest sum. The highest sum is 9. Therefore, the degree of that polynomial is 9. So in this way, if multi-variables are there, means more than one variables are there, then you can decide the degree. This is very important. Find the degree of the following: 1 marks or 2 marks. Then 2 or 3 variables will be given. If 3 are there, then add the powers of 3 variables. 4 variables, add the powers of 4 variables. If 2 variables, add the powers of 2 variables. So in this way, we can find the degree of the polynomial. Now, what is the degree of zero polynomial and constant polynomial? So next point, the degree of constant polynomial is 0. Always. The degree of constant polynomial is 0. For example, this 5 minus 6, 8, these are the constant polynomial. Then the degree is 0. And last point, the degree of, remember these points, degree of zero polynomial. If zero polynomial is there, means no term is there, is not defined. The degree of that we can't define, cannot be defined. The next point is types of the polynomials based on the degree. If degree is 1, degree is 2 and degree is 3. So these are the 3 types of the polynomial. First one is linear polynomial. First one is linear polynomial. If degree is 1, the degree of polynomial is 1. If the degree of polynomial is 1, then it is called linear polynomial. For example, this x, 3y, 5, sorry, this is the constant polynomial, then 4z, like this. So here the degree of that polynomial is 1, then it is called the linear polynomial. Second one is called quadratic polynomial. You know quadratic equations like this is the quadratic polynomials. If the degree is 2, if the degree of polynomial is 2, then it is called quadratic polynomial. For example, this x square plus 2x, then this 4y square plus 5, and this 3z square plus 2z. So here the degree is 2, therefore these are called the quadratic polynomial. Only 3z square is there, then the degree is 2, then it is called a quadratic polynomial. And last one is a third type is cubic polynomial. Cubic polynomial. If the degree of polynomial is 3, if the degree of polynomial is 3, then it is called cubic polynomial. For example, this x cube plus 2x plus 3, or this y cube, these are the examples of cubic polynomial. Degree is 3, then these are called a cubic polynomial. Now our next point is standard form, coefficient form and index form. So let us see. Here one example is given, Pm. The polynomial in variable m is equal to 3m raised to 5 minus 7m plus 5m cube plus 2. This is the given example. Now we have to write this polynomial in standard form, then in index form, and at last coefficient form. So let us see carefully how to write. So first one is standard form. Standard form means Pm is equal to, standard form means write this polynomial in the descending order. Descending यानी सबसे बड़ा फिर कम. So descending order of the powers of variable. ये जो numbers है ऊपर, यहाँ पे 5, यहाँ पे 1, यहाँ पे 3, यहाँ पे 0. So write this polynomial using the descending order. 3 m raised to 5, the highest power first. The next one 5 के बाद क्या आएगा? 3 plus 5 m raised to 3. उसके बाद क्या आएगा? 1 minus 7m, and at last constant. Constant term is always last because the power is 0. So this is called the standard form. Standard form means उसको क्या करना है खाली कि ये जो पावर है, पावर के डिसेंडिंग ऑर्डर में हम लोग को लिखना है. So write the polynomial in the descending order of the powers of variable, that is called standard form. So this is a standard form. Second one is index form. Next one is index form. So how to write this Pm? Whenever we write in index form, the absent powers means the terms with power 4 is absent. The term with power 2 is absent, means 5, 4, 2, 3, 5, 4, 3, 2, 1, 0. So this sequence must be like this: 5, 4, 3, 2, 1, 0. But this term is not there. This term is not there. This one, and this one, and this one. 4 terms are there. So write the absent terms with 0 coefficient. How? This 3m raised to 5. उसके बाद m raised to 4 आना चाहिए, but m raised to 4 term is not there. So write with 0. 0 m raised to 4. Write with 0 coefficient. That means this term becomes 0. It is meaningless. But when we write index form, we have to write that term. उसके बाद 4 के बाद 3, 5m cube प्लस इसके बाद 2 आना चाहिए, लेकिन 2 नहीं है, तो वहां पे क्या लिखेंगे? 0m square एंड माइनस उसके बाद 1, 7m and at last constant. So in this way we can write the given term or polynomial in index form. So this is called index form. Now third one is a coefficient form. Next one is called coefficient form. So same polynomial we can write using different ways. स्टैंडर्ड फॉर्म में लिखना है तो ऐसा लिखना है, इंडेक्स फॉर्म में लिखना है तो ऐसा लिखना है, और कोएफिशिएंट फॉर्म में अगर लिखना है, whenever we write in coefficient form we have to write in bracket, and coefficient form means we have to write only the coefficient of all the terms. When we first we have to write in index form and then write in coefficient form. 3, 0, कॉमा देते जाना है, 5, 0, -7, if negative then negative, +2. Remember one thing, the degree of that polynomial, number of coefficient and the degree of polynomial, these are related to each other. So how many coefficients are there? 1, 2, 3, 4, 5, 6. So 6 minus 1. So here remember one formula, degree of polynomials or polynomial is equal to number of coefficients minus 1. So this is the formula. Degree of polynomial is equal to number of coefficients minus 1. So using that formula, you can find the degree of that polynomial if it is given in coefficient form. So remember, standard form, यानी write the descending order of the powers. Index form, if absent terms are there, write with 0 coefficient, 5, 4, 3, 2, 1, 0. And only coefficient in the bracket, this is called coefficient form. How will we get degree? Number of coefficient, 1, 2, 3, 4, 5, 6. So we get degrees, 6 minus 1, 5. Now let us see practice set 3.1. The question number 1 is, state whether the given algebraic expression are polynomials and justify. Justify means give reason. So here question number 1 is that, what do we have to write? State whether the given algebraic expressions are polynomial. Means we have to decide whether the given expression is polynomial or not a polynomial. Let us see first example from this one. This y plus 1 upon y. We have to write whether it is polynomial or not a polynomial, and if it is not a polynomial, then we have to write the reason. The second example, fourth example, 2m square plus 7m plus 5. Now 3 polynomials, 3 examples are taken from question number 1. We can't solve all the examples, you can do remaining at home. So here, observe the power of the variable. Here it is 1, but here it is y raised to minus 1. So it is polynomial or not a polynomial? It is not a polynomial. So it is, how to write the answer? Not a polynomial. It is not a polynomial because, reason why I have to write, because the power of variable is negative. In second term, the power of variable is negative. That's why we can write this is not a polynomial. Here, second example. Check whether it is a polynomial or not a polynomial. 2, here the degree is 0. Means the power is 0. Here x, root x means x raised to half. How we can write this one? 2 minus 5 x raised to half. So here the power is fraction. So it is not a polynomial. So second one, it is not a polynomial because the power is, or power of variable is fraction, and whenever it is a polynomial, no need to write the reason. So here the power is 2, 1, 0 means it is a polynomial. Here in third example, it is a polynomial. We can justify our answer because the power of variable or powers of variable are whole numbers. Here these are whole numbers, and therefore we can write this is a polynomial. So this is the question number 1. Decide whether or state whether the given expression is a polynomial or not a polynomial, and we have to write the. So let us see question number 2. Write the coefficient of m cube in the given polynomial. So first example is m cube, then the coefficient is 1 because m cube, the number is not there, means 1. Then second example is minus 3 by 2 m plus m minus root 3 m cube. So what is the coefficient? m cube के साथ में जो number है वो. So here the coefficient is coefficient of m cube. We can write like this, is equal to minus root 3, right, with sign. So this is minus root 3. The number which is associated with the variable. यहाँ पे कुछ नहीं है, means 1. Question number 3. Write the polynomials. In variable x, यानी using x. So first one is the monomial. Monomial means only one term, but degree is monomial with degree 7. So how can we write? Px is equal to x raised to 7. Only one term, but degree is 7. Then third one, trinomial. Tri means 3 terms with degree 8. Trinomial with a degree 8. So we can write Px is equal to polynomial in variable x, that we have to write. So x raised to 8 plus 2x square plus 3. We can write any 3 terms, but the highest power must be 8. So it is the polynomial with degree 8. So in this way, in this third question, we can write the polynomials of your own, but the degree must be 7, 8 or the given degree is there. Now question number 4 is write the degree. Degree means the coefficient highest power of the variable. If two variables are there, then the highest sum of the powers. So here the first one is root 5. What is the degree? It is a constant. Root 5 is a constant number, that's why degree is 0. Whenever constant is there, 0. Now second is given x raised to 0. X raised to 0. So degree is 0 again. Now let us see sixth example directly. Here 7y minus y cube plus y raised to 5. The highest power 1, 3, 5. Highest is 5. Therefore degree is 5. Now let us see that example with two variables. Seventh one, 2 or 3 variable x, y, z. Here 3 variables are there, plus x, y minus z. So here sum of, here 1, 1, 1, sum is 3. Here 1, 1, sum is 2, and here sum is 1. So degree is 3. Here power of x is 1, power of y is 1, and power of z is 1. So add the powers. Here the sum is 3, here the sum is 2, here the sum is 1. So highest sum is 3, and that's why the degree is 3. So remember this one. Now last example, that's 8th one, m cube and 7. M cube n raised to 7 minus 3m raised to 5n plus mn. Now we have to write the degree of this polynomial. So find the sum of the powers. Here the sum of power is 7 plus 3 is 10. Here the sum of power is 5 plus 1, 6. And here it is 1 plus 1, 2. So highest sum is 10. Therefore degree is 10. So now question number 5 is that, so easy this practice set, basic practice set is there. Classify as linear polynomial. Linear means degree 1, quadratic degree 2, and cubic. So which one is the cubic polynomial, which one is the quadratic, and which one is the linear? So I am writing some examples here. First example is 2x degree is equal to the highest power 0, 1, 2. Degree is 2. Therefore degree 2 means it is quadratic polynomial. It is a quadratic polynomial. So how to write the answer? It is a quadratic polynomial. Here the degree is 1. Therefore it is called linear polynomial. Degree is 1, therefore linear polynomial. Here degree is here 0, 1, 2, 3. Highest power is 3. Therefore degree is 3. Therefore it is called cubic polynomial. So in this way we can decide whether the given polynomial is linear, quadratic or cubic. Now question number 6 is write in standard form. Standard form means in the descending order of their indices. Minus 7y plus y raised to 5 plus 3y cube minus half plus 2y raised to 4 and minus y square. So write in standard form py is equal to the polynomial in y, that is called py. So highest power, see the highest power 2, 4, here it is 0, 3, 5, 1. So highest power is 5. So first write the term with power 5, that is y raised to 5. 5 के बाद कौन सा आएगा 4 प्लस 2y raised to 4, उसके बाद 3 plus 3y cube. The next one is square, so minus sign is there, then minus sign, then minus 7y, and at last constant term is always at last. So in this way, this is called the standard form of that polynomial. Write in coefficient form. कोएफिशिएंट फॉर्म में लिखने से पहले उसको स्टैंडर्ड फॉर्म में लिखना जरूरी है, एंड इट मस्ट बी इन द इंडेक्स फॉर्म. सो लेट अस सी two examples from this one. The first example is x cube minus 2. Then we have to write it in standard form, then index form, and then coefficient form. Third example, दो एग्जाम्पल हम लोग साइमल्टेनियसली देखते हैं. 2m raised to 4 minus 3m square plus 7. So in this way, two examples are given. First write this in index form. So index form means write the absent terms with zero coefficient. Index form of px. So highest power is x raised to 3 plus 0 x square. X square is not there. Plus 0 x and then minus 2. Then we have to write in coefficient form. So is it clear? This coefficient form of px. So here first write in index form. While writing in index form, the degree is 3. Then 3, 2, 1, 0. That is the descending order. So write the absent terms with 0 coefficient. Now here in bracket write the coefficient of first term. Coefficient is 1, second term 0, third term 0, and last term is minus 2. So in this way we can write the given polynomial in coefficient form. 2m raised to 4 minus, so Pm is equal to 2m raised to 4 minus 3m square plus 7. Now write in index form. First we have to write in index form. Pm is equal to 2m raised to 4, उसके बाद 4 के बाद 3, 0m cube, उसके बाद 2, 3m square power 2, उसके बाद power 1, 0m, and last one is the constant. Now we can write in coefficient form. So coefficient form is equal to, in bracket, coefficient of first term, coefficient of second term, third term, fourth term, and last term. So in this way we can write the given polynomial in coefficient form in question number 7. Write in standard form. It is given in coefficient form now. So the variable you can write any, because variable is not given. The first example is 1, 2, 3. The coefficient form is given 1, 2, 3. So how to write this in index form first? First find the degree of that polynomial. Here number of coefficient, पहले हम लोग को काउंट करना है 1 2 3 3 नंबर ऑफ कोएफिशिएंट. तो सबसे पहले क्या लिखना है? नंबर ऑफ कोएफिशिएंट 3, and from that number of coefficient we can find the degree of that polynomial. Degree of polynomial is equal to number of coefficient minus 1 is equal to 2. We have written the formula. Degree of polynomial is equal to number of coefficient minus 1. So the highest power is 2. Therefore, the given polynomial is px. अगर हम लोग x वेरिएबल में लिखते हैं तो 1, the degree is 2 means x square, 1x square plus 2x plus 3, 2 1 0. The power are 2 1 0. So here the coefficient is 1, here the coefficient is 2, here the coefficient is 3. Here the coefficient form is given 5 0 0 0 minus 1. 5 0 0 0 minus 1. How many coefficient? 1 2 3 4 5. Therefore first write number of coefficients is equal to 5. Therefore degree of that polynomial is, from that we get the degree 5 minus 1 is equal to 4. Therefore the polynomial is px is equal to, so first coefficient is 5 x raised to 4 plus 0x raised to 3 plus 0x raised to 2 plus 0x and minus 1. Now in standard form, no need to write that zeros, it is index form. So 5x raised to 4 minus 1 is a given polynomial. So in this way we can write the given polynomial. If it is given in standard form, write in index form, write in coefficient form. Sometimes it is given in index form, write in coefficient form. Sometimes it is given in coefficient form, write in index form or write in standard form. So we have number 9, that is write the appropriate polynomial in the boxes. Do at home means match the pair is there, so do that at home. So here, dear student, this practice set 3.1 is completed. If you have any doubt from this practice set 3.1 and the basic concepts related to practice set 3.1, then write in a comment box. I will definitely solve that. So dear friends, if you like my video, please press the like button and subscribe my channel to get the latest update of the next videos or to get the new videos, and share it with your friends. Thank you.